Today is May 19th. Oh, and I don't think I said this yesterday. We're doing 6.2 day. I have no idea. And we're covering example 6, I believe. I think yesterday was example 4. Else I've got it completely backwards, but oh well. Our goal for the day is that we will be able to find the determinant and the inverse of a 2 by 2 matrix by hand. So we're only going to do up to a 2 by 2, and then tomorrow we're going to teach you how to use this to solve systems of equations, and that will be it for the week. So a matrix A is going to be a 2 by 2. We'll call it A, B, C, D. Has an inverse if the determinant is not 0, and if it's so a matrix is invertible if the determinant does not equal 0. If the determinant equals 0, there is no inverse matrix. And that is all. And to find the determinant of a matrix, determinant, it looks like the absolute value, but this does not mean absolute value. It means the determinant. And the determinant of A, if A is this A, B, C, D, is A times D minus C times B. So this minus that. And then if the determinant equals 0, determinant equals 0, this is a singular matrix, and there is no inverse. And you'll see why as soon as I show you how to find the inverse. And so the first thing you do to find the inverse is find the determinant. And then to find the inverse, and if you'll recall notation, A inverse to the -1, or you can barely see that, that represents the inverse. To find that, you do 1 over the determinant of A, which was AD minus CB, and you multiply that times the matrix. And what you do is you switch A and D, so this becomes D and this becomes A, and then you change the signs of B and C. So to find the inverse, you find the determinant, and another way to write that is 1 over the determinant of A, and then it's switch D and A and change the signs of negative C and B, and that is how you find the inverse of a 2 by 2 matrix. Yeah, so we'll do one example. I'll give you a your turn. And hopefully you guys can master this to be ready to be successful for Wednesday's lesson. So if I have matrix A, and it's -4, 6, 3, -5, the first thing I want to do is I want to find the inverse. So to find the inverse, I'll find the determinant, and the determinant equals -4 times -5 minus 3 times 6. So 20 minus 18, so the determinant is 2. So that's step 1. And then to find the inverse, we take 1 over 2. And then we multiply it. It's -5, -6, -3, -4. Because I switched the -4 and -5 and I changed the signs of that. And now we just do scalar multiplication. And I get A inverse equals -5 halves negative 3, negative 3 has negative 2. And then if I want to check it, I could do matrix multiplication and multiply A times A inverse. Well, I'll go ahead and do that. And that should do what we learned yesterday. And it should get us the negative 4, 6, the identity matrix. 3, negative 5. Negative 5 has negative 3. Negative 3 has negative 2. So row 1, column 1. This would be 20 divided by 2. So 10 minus 9, 12 minus 12. Ooh, negative 15 halves plus 15 halves. Whew. And then negative 9 plus 10, which sure enough is 1001. So they are inverses. That's one way you can check yourself. So here is the your turn. Oh, I'm going to turn the page. So first find the determinant, multiply by 1 over that. And so you can see if the determinant is 0, 1 divided by 0, undefined, and that is why there is no inverse, and they are called singular matrices. So here's the your turn. Oh, I should go the other way because I screwed up the other day. Oh, sorry. Your turn. Matrix B equals 4, 7, 2, 6. So find the inverse if one exists and go from there. All right, so step 1, we find the determinant. Hopefully you got it. The determinant is 4 times 6 minus 7 times 2. 24 minus 14, so our determinant is 10. Yeah? So to find B inverse, we switch 6, negative 7, negative 2, 4. Oh, Nelly, forgot to write 1/10 in front. I can just slide that in there. And B inverse equals 6/10, negative 7/10, negative 2/10, 4/10. You can leave it like this, or you could simplify to be, what, 3/5, negative 7/10, negative 1/5, 2/5. Sometimes, depending on what you're doing, if you are using the determinant, sometimes it's easier to leave it in this form, unless they all simplify. But that's it, and that's all we are doing today. We will be using this tomorrow. If you have any questions on what we've been doing in matrix multiplication, hopefully you came or you will come to our flex time today at 1 o'clock. Have a great day.